Hello everyone. I wanted to provide a proof of the hypotenuse leg theorem, which is one of the 5 ways that we use to prove that triangles are congruent. So notice that we have 3 postulates, side, 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 angle, side, angle. Those are all postulates. And then there's also the 2 theorems, the angle, angle, side theorem and the hypotenuse leg theorem, which I'll be proving here today. And I'm actually going to use, you can use either one of these 2 postulates in order to prove it, but I'm going to be using the side, side, side postulate. So this will be kind of a lengthier proof because a lot of the technical steps that I need to take along the way. So we are given these 2 triangles with these congruency markings, trying to prove that they're congruent. So again, with every proof, it's always good to start with listing out the given information. So we're given that RM is congruent to EG, AM is congruent to LG, and that these are both right triangles. So we can tell that because they've got the appropriate angle marking in there. And we're going to need that as well. So first thing I need to do is kind of get some of the technical stuff out of the way. So I want to use the definition of congruence first in order to get from the objects to the measurements themselves. So I can now say that, well, if these segments are congruent, then their measures are equal also. RM is equal to EG and AM is equal to LG, because that's what congruence means. That's the definition there. The next statement that I want to make is based off the fact that these are right triangles. I can use the Pythagorean theorems on their side lengths. So I could say that AR squared plus AM squared is equal to RM squared. I can make the same statement about the other triangle because it's right as well. So I could say that LE squared plus LG squared is equal to EG squared. Okay, I can make these claims because that is the Pythagorean theorem, which has already been proven. Now, the next thing I want to do is I want to do some substitution. So with these statements that I have right here from the definition of congruence, what I want to do is I want to take LG and substitute it in here for AM, and I'm also going to take EG and substitute it into this equation for RM. So I'll use substitution to change that equation to AR squared plus LG squared is equal to EG squared. Doing both of those substitutions in one step here. Okay, now notice I have 2 equations that are both equal to the same thing. Both of these are now set equal to EG squared. And the transitive property tells me that things that are equal to the same thing are equal to each other. So I can set these 2 sides of the equation equal to each other. So that would look like LE squared plus LG squared is equal to AR squared plus LG squared. And now I can use the subtraction property to subtract that LG squared from both sides of the equation. And then I'm left with LE squared is equal to AR squared from using that subtraction property. Now I'm going to use a property called the square root property of equality, which says that if you have a value that is positive, then the square of that value are going to be equal as well, right? So we're kind of using the reverse of the square root property of equality, or the converse, I should say. right? These have to be positive because they're side lengths, and length must be positive. So I can take the square root of both sides of these equations and say that, well, that means LE is equal to AR. Now I just need to make one final little technical step to say, well, if the measures are equal, then the objects are congruent. That means LE is congruent to AR. This is the definition of congruence. And we can go back up and put those congruency markings on there. That says LE is congruent to AR. Right, and now I've got all three sides in one triangle being congruent to all three sides in another triangle. So I can now say that triangle ARM is congruent to triangle LEG by the side, side, side postulate. And the proof is complete. Now, as I said, we could use the side, 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 or the side angle side. This would just be a couple of extra steps where you would have to go through and make the claim that angle RAM is congruent to angle ELG because they're both right angles and all right angles are congruent, and then you could say you have two sides and the angle in between them also. So this one is just kind of shorter, and for it already being such a lengthy proof, I wanted to try to keep it as brief as possible, but there it is.